All right, so we're graphing sine and cosine functions. You guys are going to be able to graph the transformations of sine and cosine functions. We'll save tangent for a little bit later. Okay? Sine and cosine functions. You did the basic parent one already for your problem of the day and the activity. So we're going to get to the transformations of those. But before we do, let's take a look at some of the features, properties of sine functions. You guys have already answered most of this already, so you should be able to fill it in. Domain of sine is negative infinity to infinity. It's not just bounded between -2 and positive. -2 pi and +2 pi. Keeps on going. The range. Are they included? Yes, they are. So they're brackets. My intercept. What is it? 0, 0. Okay, there's a graph right there of sine for you if you need it as a reference. If you can't see the ones in the pink. And what about the x-intercepts? There's a lot of them, right? They're always at the pi. So how can you represent that? Not it?
2 pi.
It would be in pi. N representing what? Any what? Any integer. So my x-intercepts would be in pi, where n is an integer. What was the symbol for integer? Oh, Z. Yep, they have to say every pi. Pi, 2 pi, 3 pi, 4 pi, negative pi, negative 2 pi, so on and so forth. Continuity is continuous.
Yes.
Okay? Oh, the whole time?
Yes.
So it's continuous. From negative infinity to infinity. Flashback symmetry. What type of symmetry does the sine function have?
X.
Say again? Origin symmetry. Y'all remember that? From like the very first unit? If it has origin symmetry, that means it's what type of a function? Odd. It all comes back. It all comes back. They haven't brought me to yet. Hopefully they'll bring something. Extrema. What did extrema mean? Maxes and mins. Do I have them? Yeah. And I want to have numerous ones, so it looks like I want to have another thing that involves n. My extrema, I'm going to have a max where? I should give myself a little more space.
Every half pi.
Every half pi?
Max.
It'll be a max at the first one we see is pi over 2, right? And then I have a min at 3 pi over 2. Where will my next max occur?
2 pi over 2. No.
If I were to keep going, where will my next max occur? 5 pi over 2. How far away is pi over 2 from 5 pi over 2?
4.
No, it's not just pi. It's not pi over 2. It's 2 pi. So your maxes are going to occur every 2 pi, starting at pi over 2. So you would represent that. You would have a max at pi over 2 plus 2 in pi. Every 2 pi, and then add pi over 2, you will have a max. Oh, I gotta do the same thing for men too. Look at these two mins. How far apart are these two mins?
Same thing.
Same thing? It is the same thing. So what do you mean same thing?
Just it's negative. It's like it'll be negative pi over 2 minus 2.
Or plus. Because n could be what? Any what? Integer. So there are your maxes and mins. That n element of z goes to both maxes and mins. I'm out of space, but you guys have plenty. Yes?
Isn't that closest then to pi one? Like,
Yeah?
you said 1 pi.
I might have said it, but I meant 2 pi. I wrote it right. So it is 2 pi. I might have said pi by accident, but it is 2 pi.
No, you said the next one was a 5 pi over 2, but
Right.
5 pi over 2 is 1 pi away.
From pi over 2.
From 3 pi over 2.
But that was doing it for the maxes, which was at pi over 2. I did these two here. Okay, so let me correct myself. Pi over 2 and 5 pi over 2 are 2 pi units away from each other. I was trying to say what was the next max that you have. And I meant to say, if I said it wrong, I do apologize. From 5 pi over 2 to pi over 2, they are 2 pi away. Okay? In behavior, what's going to happen after 2 pi? It's going to repeat. So what is my in behavior?
Well, it will go into, it keeps going to positive and negative, so how do you say both negative and positive?
You can't. In behavior, it's either going to be approaching one thing. It's either going to be approaching a number, or it's either going to be approaching positive infinity or negative infinity. Remember when you did rational functions, right? It was approaching the horizontal asymptote, or it's approaching positive or negative infinity. In this case, since sine is going to continue to go to positive 1, negative 1, positive 1, negative 1, keep going. Oscillating. It does not have an in behavior. Okay? So your in behavior for sine functions does not exist. Again, because since it's not approaching one solid number, it's just oscillating between two numbers, your y values, that's why it does not exist. Questions? Yes?
Why did you use negative pi over 2 because it was closest?
You can honestly use negative pi over 2 or 3 pi over 2, because no matter what, there's still 2 pi units away from each other. Other questions? She asked, why did I use negative pi over 2 instead of maybe 3 pi over 2? And honestly, it doesn't matter whether you use negative pi over 2 or 3 pi over 2 or the next one, because the thing is that you're going to be adding a 2 pi or 4 pi or 6 pi to get your other maxes and minimums, or your other minimums. So then that's why, you can use either. Others? All right. Cosine. Go ahead, fill in as much as you can for your domain, your range, y-intercept, so on and so forth. Give you about a minute. Domain, it's kind of what you get. Awesome. Range, Christian. Good stuff. Y-intercept, Seth.
0, 1.
I'll take a volunteer on this one. X-intercepts. See a few. Anybody on this side think they got it? That's it? That's a few? That's
Why
it?
isn't there a bracket on one?
Because it's a point. It's a point to
So
always
is
be
there
pretty
two
correct.
brackets?
All right. Let's go. Bethany, what you got?
X such that x cannot equal n times pi over 2 of x is over 4.
Say it again.
X such that x cannot equal n times pi over 2 of x is over 4.
Okay. I like you were right on about the n pi over 2 and the pi over 2n, but these are x-intercepts which do exist, so we can't say that they don't equal them. So it would just be x equals pi over 2n.
Okay.
And then not x would be an element of integers, but n. But yeah, you're right on about that pi over 2n. Does everybody see that? Every pi, or every pi over 2, you have an x-intercept. Every pi over 2, you have an x-intercept. Continuity. Brooklyn. And is it discontinuous the whole time? Or it is continuous the whole time? Okay. Symmetry. Joanna.
Is it y-axis symmetry or vertical?
Yep, it is y-axis symmetry. Very good. Which means that it is a what function in? Even. Extrema. Extrema. Chaston, what do you got? 2 pi plus n 2 pi. Okay. You can actually simplify that just a little bit. Because when you say 2 pi, n 2 pi. Yep. N 2 pi or 2 pi n. Because every 2 pi, you have a max, right? So when n is 1, at 2 pi, when n is 0, 0, n is negative 1, negative 2 pi. It continues. Very good. Anybody got the min? Trevor? Pi n? Close. Not quite. We do have a min in pi. But if I were to plug in 2 for n, I would have 2 pi, which actually would be a maximum. So I can start at pi, and then, huh? And then parentheses what? 2n? So I can like times? I can say pi, negative 1. Okay, so I have a min here. Where will my next min happen?
3 pi over
3 pi. So I have one at pi, my next one's at 3 pi, my next one after that will be at 5 pi, 7 pi, so 2 pi, who said that? 2 pi n. So I have it every 2 pi.
Can you explain that a little more?
So if I were to keep drawing out this graph of cosine, my next x-intercept would happen here. My next min would happen at 3 pi. Okay? If I were to keep drawing it here, my next min would occur at negative 3 pi. And since every min is happening basically 2 pi units away from each other, I can just pick one of my mins, one happening at pi, and then every 2 pi after that or before that, I'm going to have another min. If I were to plug in 2, this would be 4 pi. So pi plus 4 pi, I'll have another minimum at 5 pi. If I plugged in negative 2, that'd be pi minus 4 pi, which would be a negative 3 pi. So I have another min there. So this represents all the mins that happen amongst this entire domain. And of course, n is a what? An integer. And my end behavior, anybody? Does not exist. Everybody knows that D and E means does not exist, right?
No.
This is a shorthand abbreviation for does not exist, so you can use this as what? Instead of writing out does not exist, you can do D and E. Okay? Questions on the features of sine and cosine? So, both sine and cosine functions are known as sinusoidal functions, meaning both have the same shape of a sine curve. Okay, cosine is basically a sine curve, just shift it over. The general forms for these functions are y equals a sine bx plus c, and y equals a cosine bx plus c plus c. Yes, a, b, c, and d represent some numbers. Each variable has its own effect on the original graph of sine or cosine. And we're going to talk about each one of those. Now, each one of those variables, like I said, has an effect on the original graph of sine, but you already know what these are. We've done them before. With your transformations, flip over. You guys remember your rules for transformations? Some of them. When you're adding something to the original function, what does that mean? It goes up or down. If it's a plus, it means it goes up. If it's a minus, it means it goes down. Okay? What about if you have a number on the inside?
That's the opposite.
It's the opposite, which means it moves how? Left or right? How do you know it moves left?
Oh,
If
transformation.
it's positive, it goes left.
If it's positive, it goes left. If it's negative, it goes right.
So D is up or down.
Yep.
C is left or right, and then A is.
What does A do?
It stretches it or.
It does stretch it or compress it. Which way?
Vertically.
Vertically. Okay, if there's a number out front, it stretches it vertically. If there's a number on the inside, it does what? Horizontally. Okay? We did this back in lesson 1. Not lesson 1. Unit 1. One of those lessons. Alright? These are all your different transformations. You should not have forgotten them. Okay? They can be applied to quadratics, exponentials, absolute values. You guys did a foldable on it. All there. Okay? So again, these same transformations can be applied to trigonometric functions. F of x is just going to be sine x or cosine x. And then when we get to tangent, it'll be tangent x. Okay? But the same transformations still do apply. Okay?
Teachers, please pardon the interruption.
All of the f of x's are your original basic sine x, cosine x function. But g of x, there's some type of transformation.
Excuse me, teacher.
So that 1/4 in front of that sine x, what type of transformation is that?
Vertical.
It's a vertical stretch by a factor of what?
When do you flip it? Like, isn't there an instance where you flip it?
When do you flip? When do you reflect it? When there's a negative, like in B, you have a negative 3 cosine x. So that negative on the outside means it got reflected, but which way? Did it get reflected over the x-axis? It did reflect over the x-axis because it's the y is negative. What did that 3 do? By a factor of 3. What about this one?
So
Horizontal stretch, not by a third, but by 3. It's always the opposite. X over 3 is the same thing as saying 1/3 x. So it's always 1 over that number, which will end up flipping it to make it a whole number.